So in this experiment, what we're going to be doing is we're going to be verifying Hess's law. We're going to do 3 different acid-base reactions. We're going to measure their temperature over 3 minutes, and then use that data to ultimately calculate the delta H for those reactions and see if those delta H values add up the way that they should using Hess's law. So the equipment that we need for this lab, we need something to monitor the temperature. So we're going to be using our temperature probe, which is connected to our lab Quest. And then we're also going to be using a calorimeter. A calorimeter is a great device to do a reaction in when we want to isolate it in terms of heat. We don't want any outside heat coming in, and we don't want heat escaping out. There is a hole at the top of the lid here, and so that is so that my temperature probe can get inside. And then inside the calorimeter is a 150 ml beaker, as well as styrofoam. Styrofoam is a great insulator, and so that's going to help ensure that any heat that's given off by the reaction stays inside. Now, before I start doing the 3 different reactions, I do need to first determine the heat capacity of the calorimeter itself. In order to do this, what I'm going to do is I'm going to take some room temperature water and some hot water and mix them together, and then monitor the temperature every 20 seconds for 3 minutes. So I have some room temperature water here. I do need to know that initial temperature. So I'm just going to insert my temperature probe there and record the temperature in my lab notebook. And so that's reading at 22.0 degrees Celsius. Pour that in here. I also need to measure the temperature of the hot water, and then immediately get that into my calorimeter. And I am going to stir this. So what I'm going to use is a magnetic stir bar. So I'm going to put that in here as well. So just so you can see how this works, this is both a hot plate and a stir plate. So if I turn this on, you should see the little stir bar moving around there. Right, so that way I don't need to use a stir rod because I can't keep it open, right? I want this to be closed. All right, so I'm going to take my water that's been heating up on a hot plate and measure out 50 milliliters of that. Insert my temperature probe here. I want to give it about 10-20 seconds, make sure that it has an accurate temperature here. So right now it's at 59, but it's still climbing a little bit. So I'm going to give it, all right, now it's kind of stabilized. All right, so 59.8 degrees Celsius. And then I'm going to put my temperature probe in, add the warm water, stir, and then every 20 seconds, I'm going to monitor the temperature over 30 minutes. I'm sorry, over 3 minutes. So now I'm ready to start my reactions. The first reaction I'm going to do is I'm going to react 2 molar hydrochloric acid with 2 molar sodium hydroxide in a double replacement reaction. So I need to figure out the initial temperatures of my 2 reagents. So again, I'm using my temperature probe here. I'm measuring first the temperature of the sodium hydroxide. And so that is reading at 22.5 degrees Celsius. I want to just give this a quick rinse. And then I also need to measure the initial temperature of the hydrochloric acid. If they are not at the same temperature, then I will take an average of the two. But I need to know the initial temperature so that I can then figure out how much the temperature has changed during the reaction. And so they are a little bit different. The hydrochloric acid is reading 22.3 degrees Celsius. I mean, it's pretty close, but slightly different. Okay, so we're gonna give that a little rinse as well. Now, I need to get my two reagents into the calorimeter, but I need to move quickly because as soon as they come in contact with each other, they're going to react. And so I need to move quickly so that I can ensure that any heat that is produced from the reaction is contained inside this calorimeter. So it doesn't matter which one I add first. I'm just gonna pour the hydrochloric acid in here. My stir bar is already inside. And I have my temperature probe ready to go. And so now what I'm gonna do is I'm going to quickly add the sodium hydroxide. The reaction will start. I'm not gonna record the first temperature until after 20 seconds. I'm still gonna do recording the temperature every 20 seconds for 3 minutes. I will then use that data to make a graph and figure out what that instantaneous temperature was at time 0. I can't experimentally determine the temperature at time 0 because the temperature probe isn't going to record the temperature quick enough. So I'm going to extrapolate using the graph. That's why I'm monitoring the temperature every 20 seconds. All right, so everything is set up, ready to go. I'm even gonna turn the stirring on already. Again, just using a watch, a cell phone, every 20 seconds, I am then going to record the temperature. After 3 minutes, when the reaction is done, I do want to make sure that I retrieve my stir bar. I don't want it to get poured down the sink. So I'm going to use a magnetic wand. So I'll have to stick my hand inside the reaction flask. And that will grab my stir bar. And then I'm going to clean out this beaker and do the exact same thing, but for reactions 2 and reactions 3. Now, because of ammonia gas, so reaction 2 produces ammonia gas, and reaction 3, you start with an ammonia solution. So reactions 2 and 3 actually need to be done inside a fume hood. So for those, I'm gonna collect my data by doing the same process, but I'm gonna do the reactions inside a fume hood rather than on the benchtop here because of the ammonia solution. But everything else is gonna be the same. I'm gonna record the initial temperatures of the two reagents, mix them, and then record the temperature of the reaction every 20 seconds for 3 minutes.